Before we dive into today's topic, take a second to hit subscribe. Your support helps us keep researching and making these videos. Imagine yourself roughly 200,000 years ago, standing somewhere in East Africa. If you could take a snapshot of the very first modern humans and compare them to the billions of people alive today, one detail would stand out immediately. You probably wouldn't be white, and you definitely wouldn't be Asian. The earliest members of our species almost certainly had dark skin. For almost 90% of human history, everyone lived in Africa, a continent with an immense amount of constant, punishing sunlight. Exposed to intense ultraviolet radiation over thousands of generations, your cellular DNA can quietly tear apart. To counter this, human bodies deploy melanin as an internal sunscreen. These dark particles safely absorb harmful radiation before damaging fragile cells and destroying crucial folate levels. Evolution evaluates success with a painfully simple metric. Did you survive long enough to have children? In an environment flooded with intense solar radiation, possessing an abundance of melanin provided a massive, distinct survival advantage. For hundreds of thousands of years, having dark skin served as humanity's most universal biological asset, long before the modern concept of race even existed. Yet, if you look at the human population today, we span a massive spectrum. People range from extremely light to extremely dark, with thousands of subtle shades in between. Today, populations living close to the equator still possess that original, high melanin adaptation, perfectly suited for deflecting intense sunlight. Which raises a strange biological question. If this high melanin armor was the single greatest survival trait our early ancestors possessed, how and why did large portions of humanity ever lose it? The answer lies in migration. Moving out of Africa put our ancestors under a different sun, shifting the environmental variables until our greatest biological strength became a physical liability. Looking at this map, you can see how roughly 60 to 80,000 years ago, groups started migrating. They traveled through the Middle East, into Europe, and eastward across Asia. As they moved farther from the equator, the sunlight changed, and ultraviolet radiation weakened. At first glance, less radiation seems great, but the human body strictly requires a certain amount of UV sunlight to synthesize vitamin D, an essential nutrient needed to maintain strong bones and a functioning immune system. In these northern latitudes, highly effective melanin turned against its host. The biological sunscreen was so good at its job that it blocked out the tiny fraction of UV light that was actually available in the environment. Surviving in the north required a brutal biological trade-offs. Natural selection slowly stripped away that original protective layer of melanin to maximize vitamin D production. This loss of pigmentation did not happen overnight. We are looking at a localized adaptation that unfolded across enormous stretches of time. Ancient DNA shows that for thousands of years, the first hunter-gatherers in Europe retained their dark skin, pairing it with eyes that were already turning blue. The pale skin we commonly associate with Europe today became much later. It emerged as populations mixed and diet shifted heavily toward early farming, which lacked the dense vitamin D previously found in hunter-gatherer diets. Meanwhile, populations moving into East Asia encountered the exact same low sunlight problem, but they evolved lighter skin using a completely different set of genetic mutations than the Europeans. Think of it like two students taking the same math test. Both arrive at the correct answer, but they use entirely different formulas to get there. Nature doesn't follow a single rigid blueprint. Instead, evolution independently engineers its own localized solutions whenever populations face similar environmental pressures. This continuous adaptation challenges a major modern assumption. People tend to sort human skin color into three clean, tidy categories: black, white, and Asian. But as this continuous gradient shows, global environments range from intense equatorial heat to moderate, highly seasonal sunlight. Because of this, human pigmentation actually exists on a massive, unbroken spectrum. Look across the globe and you see indigenous populations, like early Australians, following completely independent evolutionary paths dictated entirely by their local solar exposure. Our species never split into neat biological boxes. We diversified continuously, gradually, and messily across every continent we touched. If you trace the genetic code of any person alive today, backward through time, all those divergent, colorful branches quickly merge directly into the exact same African source. The physical traits we focus on today represent a remarkably small fraction of our time on Earth, a blink of an eye in evolutionary terms. Those first individuals standing on the plains of East Africa were simply trying to find their next meal. They had no idea their genetics would eventually scatter, shift, and build diverse societies across the globe. Skin color is not a dividing line between different kinds of humans. It is simply a physical map of where your ancestors walked and exactly how much sunlight touched their skin along the way.